The shortest distance between the two vector equations is given by D is equal to B1 cross B2 dot A2 minus A1 vector divided by length of B1 cross B2. Vector equation of the plane in the normal form is vector R dot n cap is equal to D. The vector equation is R minus A dot n is equal to 0 and the Cartesian equation of the plane is A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in this revision session, I am going to discuss regarding the revision of part 2, that is regarding the plane in 3-dimension geometry, the derivation of the plane as well as the problems based on that. Before that, let me discuss few problems to find the distance between the lines in the first session. So that is, so in the first part we have studied equation of the line in different form. Now here let me take one small example on the equation of a line. Now find the shortest distance. Now let us come to the first problem. Find the shortest distance between the lines whose vector equations are given by vector r is equal to I cap plus j cap plus lambda into 2I cap minus j cap plus k cap and vector r is equal to 2I cap plus j cap minus k cap plus mu into 3I minus 5j plus 2k cap. Now what is required to find the shortest distance? Shortest distance is nothing but d or small d or capital D, whatever it may be. So we have to find the shortest distance for these two vector equations. So what is given equation? Given equations are vector r is equal to, first equation is I plus j plus lambda into 2I minus j plus k. Now let us compare this with vector r is equal to vector a1 plus lambda into b1. Okay, now what is a1? Therefore vector a1 is equal to I plus j and vector b1 is equal to what is b1? 2I minus j plus k. Now similarly the second equation, vector r is equal to 2I plus j minus k cap plus mu into 3I minus 5j plus 2k cap. Now comparing with r is equal to vector a2 plus mu into vector b2. Now what is vector a2? A2 is equal to 2I plus j minus k cap and vector b2 is equal to 3I minus 5j plus 2 cap. So just like this, find out the value of vector a1 b1 and a2 b2 from both the vector equations. Now what is the formula to find? Since here see vector b1 and b2 are different, so this vector b1 and b2 they are not equal. So now we can use the shortest distance formula. The shortest distance between the lines is given by d is equal to vector b1 cross b2 dot vector a2 minus a1 divided by length of b1 cross b2 vector. Now okay, this is the shortest distance. Now find out b1 cross b2 and the magnitude of this. This is determinant I, j and k. Write down the coefficients of b1. What is b1? 2I minus j plus k, 2 minus 1, 1. 2 minus 1 and 1. What is vector b2? 3I minus 5j plus 2k, 3 minus 5 and 2. 3 minus 5 and 2. Now let us simplify this. Plus, minus and plus. I into, find the value of this. Minus 1 2s are 2, minus into minus plus 5. J into, this is gone, 2 2s are 4, minus 3. Plus k into, this is gone, 2 5s are 10, minus into minus plus 3. I into, this is 3, j into 1 plus k into minus 7. So this is 3I minus j minus 7k. Find out the magnitude of this. Magnitude of b1 cross b2 is equal to root of, okay, just 3 square is 9 plus 1 square is plus 7 square is 49. So 49 plus 1 is 50 plus 9 is 59. So magnitude of b1 cross b2 is root 59. Followed? Okay. Now just find out a2 minus a1 vector. Now vector a2 minus a1 vector. Now what is vector a2? A2 is nothing but 2i plus j minus k, 2i plus j minus k, multiply the vector a. What is vector a1? I plus j, multiply by negative sign, you will get minus I minus j. So 2i minus I is I, minus 0 minus j plus j gets cancelled, 0j minus k. Now write down the dot product of these two. b1 cross b2 dot a2 minus a1, that's equal to, what is b1 cross b2? 3i minus j minus 7k dot I plus 0j minus k. Write down the dot product. So 3 into 1 plus 0 plus minus 7 into minus 1. This is 3 plus 0 minus into minus plus 7. 7 plus 3 is equal to 10. So vector a2 b1 cross b2 dot a2 minus a1 is equal to 10. So therefore the distance d is equal to, now vector the magnitude d is equal to b1 cross b2 dot a2 minus a1 is 10 divided by the length of vector b1 cross b2 is, so mod of 10 by 59, or this can also be written as 10 divided by root of 59 units. This is the distance. Okay, hope you followed. Very important problem for 3 marks. Definitely you may expect this question for 3 marks. Definite question for 3 marks for your 2022 examination. Now let us come to the next problem. Now what is the next problem? Find the shortest distance between the lines. See here, what is the vector equation given? Vector r is equal to I plus 2j minus 4k plus lambda into I plus 2j plus k, and r is equal to 3i plus 3j minus 5k is equal to mu into I plus 2j plus k. Okay, this is same as that of the previous problem, but here the value of b1 and b2 are same. So since the value of b1 and b2 are same, here let us compare with vector r is equal to a1 plus lambda into vector b1, and r is equal to vector a2 plus mu into b2. So here this is nothing but vector a1 plus lambda into, we can write b, and vector a2 plus mu into vector b. So b1 and b2 are same. b1 and b2 are is equal to same, that is equal to say vector b. That means these are nothing but the parallel lines. The previous one is the skew lines. So for skew lines b1 and b2 are not equal, since these are the parallel lines. So for parallel lines, the distance between the parallel lines is given by d is equal to, now just find out the value of a1. Vector a1 is equal to I plus 2j minus 4k, and vector a2 is equal to, this is a2 vector 3i plus 3j minus 5k, and vector b is equal to I plus 2j plus k. Here vector b is same, so they are parallel lines. So the distance between the parallel lines is given by d is equal to length of vector b cross a2 minus a1 divided by length of b. That's it. See here, the first one is b2 minus b1 dot a2 minus a1. b1, yeah, the first formula is b1 cross b2, b1 cross b2 dot a2 minus a1, whereas here vector b cross a2 minus a1 vector divided by length of b. Now find out first a2 minus a1 vector. Vector a2 minus vector a1 is equal to, what is a2? 3i plus 3j minus 5k, 3i plus 3j minus 5k minus vector a1 I plus 2j minus 4k, multiply by negative sign, minus I minus 2j plus 4k. Simplify this. So what is this equal to? 3i minus I is 2i, 3j plus 3j minus 2j is plus j, minus 5k plus 4k is minus k. Okay, now find out vector b cross, now vector b cross a2 minus a1 vector. So this is equal to the cross product, that is nothing but determinant I, j, k, and vector b. What is vector b? I plus 2j plus k, therefore coefficients are 1, 2, 1. The coefficients are 2, 1 and minus 1. Simplify this. This is I into 2 ones are 2 minus 1 minus j into, this is gone, minus 1 minus 2 plus k cap into 1 ones are 1 minus 4. So this is I into minus 3 minus j into minus 3 plus k into minus 3. So this is minus 3i plus 3j minus 3k. Find out the magnitude of this. The magnitude of vector b cross a2 minus a1 is equal to square root of 3 square is 9 plus 9 plus 9, that is root 27. Okay. What is the formula we have? So the magnitude of b cross a2 minus a1 divided by length of b. Now find out the magnitude of b. Vector b. What is vector b? Vector b is equal to I plus 2j plus k. I plus 2j plus k. The magnitude of this is length of 1 plus 4 plus 1 is root 6. So therefore the distance d is equal to magnitude of vector b cross vector a2 minus a1 divided by length of vector b. So that is d is equal to, yes, root of 27 divided by root 6. So this can also be written as, if you want, you can simplify this as square root of 9 is 3 root 3 divided by this is root 3 into root 2. This gets cancelled, 3 by root 2. So the distance d is equal to 3 by root 2 units. That's it. This is the required answer. Okay, that's it. Hope you followed. So that's all regarding how to find the shortest distance between the parallel lines and the skew lines. Now let us come to the next concept, part 2, that is the plane. Now let us come to the plane. Now in the plane, the first very important derivation we are going to study is the equation of a plane in normal form. So to derive the equation of a plane, now derive the equation of a plane in the normal form. So you may expect this question for 5 marks for your 2022 examination. Now let us derive, in the examination they may ask, derive the equation of a plane in the normal form. Now let us consider a plane whose perpendicular distance from the origin is d, which is not equal to 0. Let us consider a plane whose perpendicular distance from the origin is d. D is the perpendicular distance from the origin. So that is, here ON is the normal from the origin to the plane. ON is the normal. So ON is a normal, that is represented by ON. So here in the figure, ON is the normal from the origin to the plane, and n cap is a unit normal vector along ON. So n cap is a unit normal vector along this vector ON, and therefore vector ON is equal to d into n cap. Okay. Consider a plane whose perpendicular distance from the origin is d, that is, and therefore ON, vector ON is the normal from the origin. This ON is the normal from the origin to the plane, and n cap is a unit normal vector. N cap is a unit normal vector along ON. So therefore the distance ON is equal to d into n cap. Now let us consider a point, let P x, y, z be any point on the plane. So therefore the vector n to p, np, therefore np is perpendicular to ON. This np is perpendicular to vector ON, right? So therefore this np dot ON is equal to 0, that is np dot ON is equal to 0. See here, let P x, y, z be any point on the plane. So therefore this vector np is perpendicular to ON. Vector np is perpendicular to ON. So vector perpendicular to ON means np dot ON is equal to 0. Therefore vector np dot ON is equal to 0. So from this we can derive the equation of the plane, right? Now since vector np dot ON is equal to 0, what is np? Vector np is equal to, since we know ON, since vector ON, what is ON? ON is equal to d into n cap. Now what is np from this figure? Vector np is equal to OP minus ON vector. So np can be written as vector OP minus vector ON dot vector ON. So is equal to 0. Vector OP, what is vector OP? Vector OP is equal to R, since vector OP is equal to R minus, now what is vector ON? ON is equal to D into N cap dot ON is again D into N cap is equal to 0. Simplify this, you will get the answer. See, since NP is perpendicular to ON, therefore the dot product of NP and ON, NP dot ON is equal to 0. What is NP from the diagram? From figure, NP is equal to OP minus ON dot ON. So OP is equal to vector R minus ON is D into N cap dot D into N cap is equal to 0. Simplify this, that's it. So if D is not equal to 0, for D is not equal to 0, this can be written as vector R minus D into N cap dot N cap is equal to 0. Now, this can also be written as R dot N cap minus D into N cap dot N cap is equal to 0. Since N cap dot N cap is equal to 1. So, this is R dot N cap minus D into 1 is equal to 0. That is vector R dot N cap minus D is equal to 0, or R vector dot N cap is equal to D. So therefore vector D is equal to vector R dot N cap is the vector equation of the plane, right? Therefore the vector equation of the plane, therefore the vector equation of plane is vector R dot N cap is equal to T. That's it. Very simple, very simple. See here, since NP dot ON is equal to 0, NP is equal to OP minus ON dot ON, OP is equal to R and ON is equal to D dot D into N cap. So R minus D N cap dot D N cap, just when D is not equal to 0, then this is very small, that is D into N cap is equal to N cap, just multiplied R dot N minus D into N dot N cap into N cap. Since N cap is a unit vector, N cap into N cap is equal to 1. So this is 1. R dot N minus D into 1 is D. This is D. So therefore R dot N minus D is equal to 0, or R dot N cap is equal to D. Hence the vector equation of the plane in the normal form is vector R dot N cap is equal to D. Now let us come to the Cartesian form. Okay. Now what is P here? Since P x y z be any point, therefore the position vector of OP is equal to vector xi plus yj plus zk. What is the position vector? This is nothing but vector R. So vector R is equal to xi plus yj plus zk. Right. Next. So from vector equation, of plane, what we have, vector R dot N cap is equal to D. Since vector R is equal to, what is vector R? Xi plus yj plus zk, right? Now suppose if L, M, N are the direction cosines, if L, M, N are direction cosines of N cap, then vector N cap is equal to L into vector I plus M into vector J plus N into vector K. That's it. Okay. Substitute here. Now what is R? That is nothing but vector Xi plus Yj plus Zk dot, what is N cap? N cap is vector L into I plus M into vector J plus N into vector K is equal to D. Now just apply the dot product. So this is X into L plus Y into M plus Z into N is equal to D. So therefore the combined equation is L into X plus M into Y plus N into Z is equal to D. This is the vector Cartesian equation. So therefore the vector equation of the plane, is vector R dot N cap is equal to D. The Cartesian equation of the plane, is L into X plus M into Y plus N into Z is equal to D. This is the Cartesian and the vector equation of the plane in the normal form. That's it. Okay. Very simple. Just substitute the value of R and N cap. R dot N cap will give us Lx plus My plus N into Z is equal to D is the vector and Cartesian equation of the plane. Definitely you may get this, you may expect this type of question for 5 marks in the derivation part. Okay. Now let us come to the next problem based on this. Find the vector equation of the plane which is at a distance of 6 by root 29 from the origin and its normal vector from the origin is given by vector 2i minus 3j plus 4k cap. So let us take this problem based on this derivation. Now what is given? Given that the distance d is equal to 6 by root 29 and normal vector is given by vector n is equal to 2i minus 3j plus 4k cap. This is given. Okay. What is required to find? Find the vector equation. That's all. Okay. So what is the vector equation? The vector equation of the plane is vector r dot n cap is equal to d. Since we know the value of d, find out r dot n cap. Now first find out the value of n cap. Vector n divided by its own length will give the unit vector along n. So this is vector 2i minus 3j plus 4k divided by length of 2 square is 4 plus 9 plus 16. So this is 2i minus 3j plus 4k divided by 16 plus 4 is 20 plus 9 is 29, root 29. So first find out the unit vector n cap along n. The unit vector n cap along vector n is given by vector n divided by its own length 2i minus 3j plus 4k divided by square root of 2i minus 3j plus 4k mod, that is square root of 4 plus 9 plus 16, that is root 29. Substitute here. What is the vector equation? R dot n. Vector r dot n cap is equal to vector 2i minus 3j plus 4k cap divided by 29 is equal to d. D is equal to 6 by root 29. That's it. So therefore the required equation is r dot n cap is equal to d, means therefore vector r dot this vector 2 by root 29 into I minus 3 by root 29 into j plus 4 by root 29 into k cap is equal to 6 by root 29 will give the vector equation of the plane, which is at a distance of 6 by root 29 from the origin, and its normal vector is 2i minus 3j cap plus 4k cap. That's it. Now let us come to the next derivation. This is also very important for 5 marks for your 2022 examination. The equation of a plane perpendicular to a given vector and passing through a given point. First one is the normal form. The second one is equation of a plane perpendicular to a given vector. This is perpendicular to a given vector and passing through a given point. Okay. Now let us come to this derivation. Now let us draw the diagram. Let a plane passes through a point A. This is the point. Let a plane passes through a point A with position vector. The position vector of A is vector OA is equal to vector A. Let a plane, this plane will passes through a point A whose position vector is vector OA is equal to vector A, and this is parallel to the vector n, and this is parallel to the vector n. Okay. And let R be the position vector of any arbitrary point P, X, Y, Z, and whose position vector is given by vector OP is equal to vector R. Then the point P lies on the plane if and only if this line AP is perpendicular to N. This is very important. That is, the point P lies on the plane if and only if this AP is perpendicular to vector N. So AP is perpendicular to vector N. This is the construction per se. Let us consider it. Let a plane passes through a point A whose position vector is vector OA is equal to A, and this plane is perpendicular to the vector N. Perpendicular to the vector N. Let R be the position vector of the point P, X, Y, Z in the plane. The point P, this point P lies on the plane if and only if AP is perpendicular to vector N. AP is perpendicular to vector N. What is the meaning? AP is perpendicular to vector means vector AP dot n is equal to 0. That is, vector AP dot n is equal to 0. Since what is vector AP? AP is equal to vector OP minus OA vector. OP is nothing but vector R minus vector A. So this is vector R minus vector A dot n is equal to 0. So therefore, vector R minus vector A dot vector n is equal to 0 is the vector equation of the plane. That's it. So the vector equation of the plane perpendicular to a given vector and passing through a given point is vector r minus a dot n is equal to 0. That's it. Okay. To find the Cartesian form, let the point A, let A, the point A be x1, y1 and z1. So therefore, portion vector of A is vector OA is nothing but vector A is equal to x1i plus y1j plus z1k. And the position vector of the point P xyz, P is xyz, therefore vector OP is equal to vector R is equal to xi plus yj plus zk, right. A is equal to x1i plus y1j plus z1k and OP vector R is equal to xi plus yj plus zk, right. And suppose if A, B, C are the direction ratios of n, so then the vector n is equal to ai plus bj plus c into k, where a comma b comma c are the direction ratios. Suppose if a, b, c are the direction ratios of the line of n, then vector n is equal to ai plus bj plus c into k. Now first find out vector r minus a. Now vector r minus a is equal to, what is vector r? Xi plus yj plus zk minus vector a. What is a? A is equal to x1i minus y1j minus z1k. Now simplify this. That is vector r minus a dot n is equal to 0. R minus a is x minus x1 into I plus y minus y1 into j plus z minus z1 into k. See here, x minus x1i plus y minus y1j plus z minus z1k is the dot n. What is n? When vector n is equal to a into I plus b into j plus c into k. That is vector a into I plus b into j plus c into k cap is equal to 0. Now just put the dot product for these two. So what you will get? X minus x1 into a plus y minus y1 into b plus z minus z1 into c is equal to 0. That's it. So therefore, a into x minus x1 plus b into y minus y1 plus c into z minus z1 will give the Cartesian equation of the plane. So is the Cartesian equation of the plane. Cartesian equation of plane. That's it. So the vector equation is r minus a dot n is equal to 0 and the Cartesian equation of the plane is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Very simple. These two derivations are very important. Either you may expect one derivation from a line or one derivation from plane. Okay, that's it. So let us take few problems on this. Right. Now let us come to a problem. Find the vector and Cartesian equation of the plane which passes through the point 5, 2, minus 4 and perpendicular to the line whose direction ratios are given 2, 3, minus 1. Okay, this is also a very important problem indeed for 3 marks. Now, what is the point given? 5, 2, minus 4. Therefore, the position vector of A is vector A is equal to 5i plus 2j minus 4k. This is given. Further, what is given? And perpendicular to the line whose direction ratios are given. So if the directions are given means then the normal vector n is given by 2i plus 3j minus k cap. So vector A and the normal vector n are given. So what is required to find the vector and Cartesian equation of the plane? That's it. Now first write down the vector equation. The vector equation is vector equation of plane is vector r minus a dot n is equal to 0. Vector r minus a. What is r? We can take r minus a. What is vector a? 5i plus 2j minus 4k dot vector n. N is equal to 2i plus 3j minus k is equal to 0. That's it. Since what is r? R can also be written as xi plus yj plus zk, xi plus yj plus zk minus 5i plus 2j minus 4k dot 2i plus 3j minus k is equal to 0. This is the vector equation. That's it. Okay. So, this is the vector equation of the plane. Now, to write the Cartesian form, the Cartesian equation of plane. So, from vector form, what is the vector form we have from the previous page? Xi plus yj plus zk minus 5i plus 2j, 5i plus 2j minus 4k dot, what is dot product? 2i plus 3j, 2i plus 3j minus k is equal to 0. Now, let us simplify this. If we simplify, what you will get? X minus 5 into I plus y minus 2 into j plus z minus into minus plus 4 into k dot 2i plus 3j minus k is equal to 0. Now, write down the dot product for these two vectors. So, this is x minus 5 into 2 plus y minus 2 into 3 plus z plus 4 into coefficient of k is minus 1 is equal to 0. Simplify this. So, this is 2x minus 10 plus 3y minus 6 minus z minus 4 is equal to 0. Put it in order. So, 2x plus 3y minus z, so is equal to minus 10, minus 6 minus 4 is minus 10 is equal to 0. That is 2x plus 3y minus z is equal to minus 20, transferred minus to minus 10, minus 10, minus 10 is minus 20 to the right hand side. It becomes plus 20 is equal to 0. That's it. This is the required equation. This is the vector equation. And the Cartesian equation is 2x plus 3y minus z is equal to 20 is the Cartesian equation. Very important problem. Now, let us come to the next problem. What is the next problem? Find the vector equation of the plane passing through the points. There are 3 points. So, the vector equation. Find the vector equation of the plane passing through 3 points. What are the points given? So, position vector of R is vector A is equal to 2i plus 5j minus 3k, and position vector of S is vector B is equal to minus 2i minus 3j plus 5k vector, and the position vector of T is vector C is equal to 5i plus 3j minus 3k. These are the position vectors of R, S and T as vector A, vector B and vector C. Now, the vector equation of the plane passing through these 3 points, the vector equation of the plane passing through R, S and T is vector R minus A dot vector RS cross vector RT is equal to 0. That's it. Vector equation of the plane passing through the points R, S, T is given by vector R minus A dot vector RS cross RT is equal to 0. Now, just find out what is R minus A, RS and RT. That's it. Okay. Now, this is nothing but that is vector R minus A dot, what is RS and RT? That is nothing but vector B minus vector A. Vector B minus vector A cross T. What is T? Vector C. That is vector C minus vector A is equal to 0. That's it. Here, just find out the value of B minus A and C minus A cross product. Vector B minus A, what is B minus A? Minus 2i minus 3j plus 5k minus A minus 2i minus 5j minus into minus plus 3k. So, this is equal to minus 4i minus 8j plus 8k. This is vector B minus A. Similarly, find out vector C minus A. Vector C minus A can be written as, what is vector C? 5i plus 3j minus 3k minus A minus 2i minus 5j minus into minus plus 3k. This can be written as 5 minus 2 is 3i plus 3 minus 5 is minus 2, and minus 3 plus 3 gets cancelled, 0 into k. Okay. Now, substitute here. So, therefore, this vector R minus A dot vector B minus A cross vector C minus A is equal to 0 is given by vector R minus A dot vector B minus A. What is B minus A? Minus 4i minus 8j minus 4i minus 8j plus 8k cross C minus A. What is C minus A? 3i minus 2j. 3i minus 2j is equal to 0. That's it. So, if you want, you can further simplify. That is vector R minus A. What is A? 2i plus 5j minus 3k. That is 2i minus 5j plus 3k dot this minus 4i minus 8j plus 8k cross vector 3i minus 2j is equal to 0. This is the vector equation of the plane. That's it. So, now equation of the plane in the intercept form. Find the equation of the plane with intercepts 2, 3 and 4 on the x, y and z axis. Now, we know the equation of the plane in the intercept form is equation of plane in intercept form. So, the equation of the plane in the intercept form is, we know this, x by a plus y by b plus z by c is equal to 1. Now, what is given here? Find the equation of the plane whose intercepts are given. A is equal to 2, b is equal to 3 and c is equal to 4 on x, y and z axis respectively. So, therefore, the equation of plane is x by a plus y by b plus z by c is equal to 1. What is a? What is a is 2 plus y by b is 3 plus z by c is 4 is equal to 1. So, if you want simplify, you can take LCM and simplify it. That's it. Okay. Now, further, if you want, you can simplify by taking the LCM. What is the LCM here? So, this implies 12 is the LCM. For 2, 3 and 4, 12 is the LCM. So, 6x, this gets cancelled 6 times, 6x plus 3 4s are 12, 4y plus 4 3s are 12, 3z is equal to 1. So, therefore, the required equation is 6x plus 4y plus 3z is equal to 12 is the equation of the plane in the intercept form. That's it. Okay. Hope you followed. Now, let us come to the next problem. Find the intercepts cuts off by the plane. So, here we have to find the x, y and z intercepts. So, what is given? 2x plus y minus z is equal to 5. Divide by 5. So, this is 2x by 5 plus y by 5 minus z by 5 is equal to 5 by 5. So, this is nothing but x divided by 5 by 2 plus y divided by 5 plus this is z divided by minus 5 is equal to 1. So, comparing with x by a plus y by b plus z by c is equal to 1. So, therefore, x intercept a is equal to 5 by 2, y intercept b is equal to 5 and z intercept c is equal to minus 5. So, 5 by 2, 5 minus 5 are the values of a, b and c. That's it. Very simple for 1 mark or 2 marks. Okay. Now, let us come to the next problem. Find the angle between the plane 2x plus y minus 2z is equal to 5 and 3x minus 6y minus 2z is equal to 7 using vector method. Find the angle between the two planes. So, we have to find the angle of intersection between the two planes again. So, the angle between the two planes is nothing but the angle between their normals. Now, what is given here? This is the normal equation, vector r dot n cap is equal to d. So, find out the angle between their normals. So, vector n1 is equal to 2i plus j minus 2k cap and vector n2 is equal to vector 3i minus 6j minus 2k cap. That's all. The angle between n1 and n2 is given by cos theta is equal to vector n1 dot n2 divided by length of n1 into n2. That's it. So, find out the dot product of n1 and n2. n1 dot n2 is equal to 2 into 3 plus 1 into minus 6 plus minus 2 into minus 2. So, 6 minus into minus plus 4. This is equal to 4. And length of n1 is square root of 2 square is 4 plus 1 plus 4. This is root 9. Square of 9 is 3. Similarly, length of vector n2 is equal to magnitude of 3 square is 9 plus 6 square is 36 plus 4. So 36 plus 4 is 40 plus 9 is 49. Square root of 49 is 7. So this is equal to n1 dot n2 is vector n1 dot n2 is 4 divided by 3 into 7. This is 4 divided by 21. So therefore, the angle between the vectors theta is equal to cos inverse of 4 by 21. That's it. Okay. So therefore, the angle between these two is plane is given by theta is equal to cos inverse of 4 divided by 21. That's it. Now let us come to the next problem. Find the distance of a point 2, 5, minus 3 from the plane. So distance of a point 2, 5, minus 3 from the plane, the r dot 6i minus 3j plus 2k cap is equal to 4. Okay. See what is the problem given? The point is given and this is of the form vector r dot n is equal to d. What is n here? Vector n is equal to 6i minus 3j plus 2k and d is equal to 4. And this is the point vector a is equal to 2i plus 5j minus 3k. That's it. The distance of the point P 2, 5, minus 3 to the plane is given by, therefore the distance is equal to, so the distance is equal to the dot product of vector A, that is 2i plus 5j minus 3k dot n, a dot n, that is 6i minus 3j plus 2k minus d. What is d? D is equal to 4 divided by the magnitude of n, that is 6i minus 3j plus 2k. That's it. So if you simplify this, you will get the distance. That's it. 6 2s are 12, minus 5 3s are 15, minus 3 2s are 6, minus 4 divided by root of 3 6 6 are 36, 3 3s are 9 plus 2 2s are 4. So that's equal to 12 minus 15 is minus 3, minus 3 minus 6 minus 4 is minus 13 divided by 36 plus 4 is 40 plus 9 is 49, square root of 49 is 7. 13 divided by 7. So therefore, the distance is 13 by 7. So the distance between the point and the plane is 13 by 7. That's it. Okay. Now let us come to the next problem. The last problem in this. Find the angle between the line and the plane. See, so far we have determined the angle between the lines and also the angle between the planes. Here the angle between the line and a plane. So to find the angle between line and plane, just find out the vector equation for this. The vector equation for the line is, what is the vector equation? We have vector r is equal to a plus lambda into b. Now vector r is equal to a plus lambda b, that is minus I plus j plus 3k plus lambda into vector b. B is nothing but 2i plus 3j plus 4k. This is the vector equation of the line. Okay. Similarly, the vector equation for this line is vector r dot, what is this? Vector 2i plus 2j minus 5k is equal to 2. That's it. These are the vector equation. Now find the angle between this plane and the line. Okay. Now what is the value of b here? So find out b. Vector b is equal to, vector b is equal to 2i plus 3j plus 4k, and vector n, what is n? This is r dot n is equal to d, r dot n is equal to d. Therefore vector n is equal to, vector n is equal to 2i plus 2j minus 5k. So the angle between the line and the plane is given by sin pi is equal to magnitude of this b dot n divided by length of b into length of n. That's it. The angle between the line and the plane is given by b dot n divided by length of b into length of n. That's it. Simplify this. This is equal to, so 2 into 2 plus 3 into 2 plus 4 into minus 5 divided by the square root of 2 square is 4 plus 3 square is 9 plus 4 square is 16 into root of magnitude of n. 2 square is 4 plus 4 plus 25. 4 plus 4 plus 25. Simplify this. That's it. So this is equal to mod 2 2s are 4. This is 4 plus 3 2s are 6 plus 5 4s are 20 divided by 16 plus 4 is 20 plus 9 is root 29 into, so 25 plus 4 is 29, 29 plus 4 is root 33. So this is equal to 4 plus 6 is 10 minus 20 is minus 10 divided by root of 59 into 33. So therefore sin pi is equal to 10 divided by root of 29 into 33. That's it. This is the angle between the line and the plane. That's it. Okay. So that's all regarding this session. Let us meet with the next chapter in the next session. Thank you. Thank you very much.